Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good morning, I bid to all. So, to continue with the ICAES 2023, this is my topic, which is entitled Topology Optimization and Mechanical Property Studies on Total Knee Replacement, TKR, using finite element simulation method. So, I don't want to drag too long for my presentation. So I will continue straight into our next slide, which the content for my presentation consists of five parts, which is introduction, knee implant design and material, methodology, result and discussion, and the last one is the conclusion. So as an introduction, this figure shown a meeting point of two long bones in the leg. So as you know that uh, the research here is about the knee. So it's supported by the complex network of muscle, ligament, and tendons. Knee implant, also referred as a KA or knee arthroplasty or TKR, total knee replacement, are a surgical method that used to replace the patient knee joint. So this treatment is particularly good in release pain, and restoring the function depends on the individuals. But most cases it will be on the severe arthritis. So there are many type of arthritis, but mostly is rheumatoid arthritis, which lead to inflammation of the synovial membrane, which is the liquid, resulting in the excessive of synovial fluid and pain and also stiffness. So many cases, but most of the cases related to the arthritis. So I don't want to drag too long, so we go straight into the knee implant design. So I will briefly explain to all of you that we have a three main implant design. So the most common one is the posterior stabilized and also the cruciate retaining. So the A and B. So for this one is the mostly common use. We can see that from the tibial component, the connector between the tibial and also the femoral. Femoral is the up one, and the tibial are the lower part. And then the other one, the latest one, which tried to introduce by the surgeon and the market demanding, which is by cruciate retaining. So the difference between this part is on the what we want to achieve from the surgery. So either we want to achieve on the posterior or anterior. So this means if you familiar with the word of the ACL, if you're playing football, then we will be uh, very prone to the injury for the ACL. So this is one of the common method lah, depends on the ACL or the PCL, posterior or anterior. So in my method, okay, for this topic which we learn about the topology optimization, so we already developed of a new design based on the BRD, what we call it as a B cruciate design. So we try to improve from the design that already in the market, and then we try to put topology optimization on that material itself. So this is the first part that we can see that we try to design, and then we put the material properties based on the previous research, and then we put three loading condition, which is normal, which is like a standing, walking, and also the last one is jogging. So this is all from the reference on the previous paper. So on the loading and the boundary condition, you can see from that figure, and also you can read from my paper, you can see that at the tibial component, we fix and also we put a loading condition on the femoral component. So from the result we do on the finite element using the ANSYS workbench, you can see that the femoral component only that will be optimize. So we don't want to drag too many part on the tibial component. So you can see that after we optimize, you can see the gray area which maintain, and the brownish is after we make a optimization. So after we make a fine refinement, so this process will take a very long process. I bet to all of you. So it's very difficult to matching the mesh and nodes, mesh element nodes and sort of things. So we came up with this new design, which we after we make a few refinement on our work. So in our analysis, FEA analysis, we try to establish on three main part, which is the total deformation, void Miser stress, and also the shear stress. Okay, if you look into this part, you can see that it is directly proportional for the total deformation. That means that after uh, you running, okay, or you jogging, the deformation is quite higher compared to the you walking and also standing. So this is on the part of the total deformation. For von Miser stress also it looks similar, but I want to highlight the different, which is on the maximum shear stress. So you can see that maximum shear stress happen the highest during walking. Okay, the second picture in here. So why is it so? Because during the walking, the knee, okay, the knee joint experience the cyclic loading, okay, due to alternate stance and swing phases. So this cyclic loading will create dynamic shear force. So it will lead to the higher stress level. On the other hand, during the jogging, the increase and the intensity of the higher impact force will lead to dominant compressive force. So that's why during the jogging, a rapid force cause the vertical ground reaction and increase compression to the knee plant, the knee joint. So what I want try to say is consequently the compressive force tends to dominate over the shearing force. So resulting in the lower shear stress compared to the walking. So that's why the walking get the higher maximum shear stress. So this study is supported with the previous research lah. Okay, that you can read on my paper also. Right, and then the last one which I want to highlight is about the topology optimization. That's after we conclude everything and we put into the graph, you can see that comparison before and after optimization. We try to cap it at a 5 degree, 5% difference on the result. So we put analysis, final element analysis before the new design or also the after new design. We kept at the 5% difference. We can see that we can reduce the design by 23.96%. What it's mean by the reduction 23.96% is the mass of the model. So we can reduce the material consumption, and also we can reduce the cost. But it will not compromise the mechanical properties part on this new design. So what this research try to give is in terms of uh, budget, okay, or we try to improve on the cost effectiveness. We can use topology optimization to reduce on the material consumption. So in conclusion, so the study highlight the direct relationship between the loading condition and the total deformation, von Miser stress, and also the shear stress. So higher level of activity will increase deformation stress and shear stress based on the logic, the engineering part. But we have to alert also on the maximum shear stress. So topology optimization analysis demonstrate that the mass of the ephemeral component can be reduced by 24% while maintaining around 5% difference in terms of mechanical properties. Right? But then you have to remember that my research in here is based on the mechanical properties part only. So we have a boundary condition that we cannot compromise too much. Okay, but if you take into account another boundaries, then there is other cases. Right, I think that's all from my presentation. I think around 10 minutes, that should be okay. So thank you, and if you have anything else, you may contact me through my email or my phone number. Right, thank you.